Okay, so let me walk through this and make sure that I understand. Um, you have looked at caves in northern Siberia, which have been where where the
So,
ground has been frozen for quite some time.
yeah, it's not northern Siberia. Northern
Okay,
Siberia, it's much further to the north.
okay,
Uh, I looked from latitude 60, which is central part of eastern Siberia,
okay,
further to the south to Lake Baikal, and then further to Mongolia, approximately till latitude 42.
okay. So you looked in Siberia at you looked at caves where the ground has been permanently frozen. You looked
Yeah.
in areas where it is discontinuously or intermittently
Yes.
frozen, and then you
Yes.
looked in areas where it has not been frozen.
Yes, actually, the cave near Lake Baikal, it's the Ochotniche cave, is almost, I think there is permafrost of maybe less than 10% about, of patches of permafrost in this area. So it can be considered almost not frozen area. Now in Mongolia, the caves are in the desert. There is no permafrost in Gobi Desert. It's much warmer area. But there the target was completely different. We wanted to track desert aridity in the past and not the permafrost.
Right,
And it was secondary target. Main target was the permafrost in the north.
right. And so uh, the message of your research for us is that somewhere around 1.5 degrees C above pre-industrial temperatures globally,
Yes.
that is when we would see continuous permafrost areas begin to melt.
Yes.
And how long of a process is that on human terms?
Well, it will take. It's not what we can. We couldn't find it by our means. Yes, so I think we here we will need other research, other types of research that make modeling of permafrost and seeing how what's the actually the time scale of permafrost degradation, because. In our caves, when we start seeing dripping in the cave, it still can be that part of the area above the cave is frozen, but the permafrost is not continuous, so water starts to come. So we cannot, from our research, we cannot uh, conclude quantitatively about the timescales of how long it will take. I think we will need more, maybe more research in the northern part of Siberia, for example, in area of latitude 65-70, where the permafrost is continuous and thick. And this is actually our future research. When we will be able to know if these areas responded to this slight warming of 1.5 degree, or the permafrost there haven't responded. And But I think about the scales of permafrost melting, we need much higher resolution research. For example, today the errors of dating, of uranium thorium dating, is between, let's say, few per mil to several percent. It depends if it, for example, if it's young ages, are there several per mil. Then if they are close to the boundary of the method is good until 500,000 years or slightly more, then it's several percent. So what to actually measure when caves started to thaw, for example, in near Lake Baikal, if we uh, date stalagmites when they started to thaw, started to drip in the beginning of the Holocene, for example, and see how the thawing above the cave progresses and when they start dripping in each time. I think it's much more higher resolution research that we need to do, and it was, I think, beyond the scope of what we did now.
Is there another method of dating that would give you higher resolution?
I don't think so, because this method is quite good. What it's possible to do is to try, for example, in one of the caves near Lake Baikal, starting monitoring when stalagmites started to when they started to grow, for example, in one of the younger periods in beginning of Holocene, and how quickly, for example, these stalagmites started to grow in entire cave. Yes, but I think this is a separate study. So we need to just to make this. We need much more samples and much more ages
Okay,
to find the time scale of permafrost degradation.
okay. So take-home message for us in terms of our way forward is that we are already about halfway to that 1.5 degrees C warming from pre-industrial times.
Yes.
And so that's telling us that we have relatively small margin before that permanent continuous permafrost would begin to break down.
This you should ask the modelers of. Today, there are many scientists that modeling the global warming, and they have more idea how fast, which scenarios we will have in the future, and how fast we will make another half of the warming.
Okay.
But I cannot say you about it when exactly we will reach this threshold from our research. But there are a lot of modeling effort in this area. So I think for risk assessments, there should be combination between results of our research and results of modelers.
Well, okay, I find this research fascinating and very important, and I hope to share it with some of the viewers at the Yale Climate Forum. So, is there anything I should have asked you that I did not?
I don't know. I think you should maybe, if you make some article about it, just mention that it was international effort. It was impossible to do it alone, so many people participated in it. And there was done a lot of work, especially by a Russian party from Institute of Earth Crust in Irkutsk, Arabica Caving Club, the Geography Institute of Mongolian Academy of Sciences, and ETH Switzerland.
Very good.
Yeah.
Okay, well, I thank you very much for your time. I will look forward to further research.
Thank you. And this study was funded by NERC, Natural Environment Research Council of Britain, and also by Russian Foundation for Basic Research and for Royal Society.
Great.
And yes.
I really appreciate your work, and I look forward to seeing where this leads. Thank you so much for your time.
Thank you very much.